Hello out there. In this video, I'm going to briefly go through an application that implements some simple React server-side rendering, or SSR. I won't go into too much detail about why you might want to do this, but in a nutshell, SSR allows you to pre-render your React application server-side before you deliver the initial payload to the client. Um, Also, quick disclaimer, throughout this video, you'll hear me using an acronym soup and calling it RSC and RSR and all sorts of wrong things. Um, Ignore that. What I mean to be saying is SSR, server-side rendering. Yeah, so enjoy. I'll just kind of quickly step through this application and build it up a little at a time, adding to the complexity as I go along. So what I have here is a really simple demonstration app. The purpose of this app is to try to show React side rendering and specifically how we can use it to deliver titles and metadata dynamically, hopefully with the extended goal of keeping the logic for those dynamically generated titles and metadata inside of the React application itself. That way we can treat them as, part of the general presentational logic of React. I'm trying to keep this all very simple and bare bones, to learn, and also so that this approach can be applicable to existing legacy projects that might be hard to convert to something like Next.js. A quick tour of the application in its current state. I think you'll notice pretty quickly that we're not quite done yet. But what we have here is we have a very simple React application. All it really does is just returns some basic scaffolding. We're just going to see welcome to RSC. And we are leveraging React Helmet to update the title. And the sorry, I keep saying the acronym wrong, but RSR, React Server-Side Render part comes in over here. We have this index public HTML, which is, it's serving, you'll see here, this title, RSC untouched title, which should really be RSR. And just this empty body here, right? And you see here, we have this very simple server that is just acting as a static asset server for everything in dist, unless it's not there, in which case it basically reads in this index.html and it uses the React server DOM render to string to render our application component over here on the server, and then to replace that empty app div with an app div that's got the rendered results of our React application. And what you'll see here, if we go over here, okay, it looks like it's working, right? We have our title, much dynamic, much server. Wow. We have our welcome to RSC. But what happens if we curl this? Go back in my history a bit here. If we curl this, what you'll notice here is that our RSR, or RSC as I mistakenly called it earlier, title is still untouched. But it wasn't a total failure because we do have our welcome to RSC. So the basics of the React server-side rendering is working, but it's not quite picking up the changes from Helmet. Now that's not entirely shocking to me. I hadn't really delved into Helmet too much or used it much before, but I was pretty much expecting to see something like that, knowing a little bit about how I would go about setting a title dynamically in a React app. But fortunately, Helmet does have us covered here. This isn't the most ergonomic thing in my opinion, but it does explain here that basically if you're going to use it on the server, what you need to do is you need to call this ReactDOMServer render to string method basically after you've, or this or this helmet.renderStatic, you basically invoke this after you've called the ReactDOMServer render toString method. So you'll first invoke this to render your application like we're doing here. And then after that, you go back and you call helmet render static, and then you have to do some manual string replacement yourself. Okay, so second pass at this, updating the project with our new knowledge from the React Helmet documentation. What we've done here is we've just put a little comment placeholder in our HTML file. And now over here, once we've called our render toString, we're going to call our helmet render static, and we can extract the title that was built by the React application logic from helmet here. And then we can do simple string replacement to plop that title in. Now, I don't really recommend this approach of simply reading in the index HTML file like this and doing string replacement, or at least I certainly haven't settled on it yet. That feels pretty messy. If you're going the Node route, Node has quite a bit of templating engines available, so I'm thinking that long term I'll probably swap some of this out with something like Pug. But in any event, what you'll see here is once we have that, if we do our curl again, we now get our proper much dynamic, much server rendered out here from the initial request from the server. And we can, re-render over here. We see the same thing. Okay, so the next thing I want to add to this in terms of complexity is the React router DOM. So if we're going to demonstrate that we can have dynamically generated titles and metadata based on route, then we are going to need more than one route in our application. So a couple things have changed here worth noting. One thing is we have pulled in our React router DOM, and we're using the browser router here in the root of our client-side application. And you'll notice here that we have done this outside of our application component. So by wrapping our application component in this router here, we're injecting everything that we need in order to be able to make use of React router DOM. But again, important to note, we've done it outside of the context of our application. There's a reason for that, which we'll come back to. So here inside of our application, things have gotten just a little more complicated here. I've thrown in just a header section with some links to navigate around, making use of the React router DOM link component here, which means that when we click these links, it will be attempting to do client-side routing. Also here, we have our switch statement set up, which is how we define different routes within the context of the React router DOM. So we just have two routes right now. We have an about, and we have our slash, our home route. You'll notice I've removed the calls to helmet from this app component. Instead, those have now been pushed out to our various pages. So we have helmet here saying React SSR with TypeScript about page. Same thing in home, except React SSR with TypeScript -home. Now, coming back to why we did not stick that router in our app component, we go over here and look at the server. And in the server, what we need to do is the server can't actually use the router, the browser router. It needs to make use of a slightly different component provided by React Router DOM called static router. So everything's going to be the same here, except that instead of wrapping our app in the browser router, we just wrap it in static router, and we thread through the URL from our request, and we'll give it a default context Minor side note here, you'll notice I'm now able to inject JSX in here into my server code. That wasn't possible in my earlier configurations I was using in these videos. A minor change I made to that, you'll notice here file name is changed to .tsx, and a little bit of tweaking was done in the webpack config here to make sure that tsloader includes both the source directory and our server directory. So that allows us to properly leverage Typescript as well as JSX here inside of our server. So it makes things a little cleaner. Other than that, not too much has changed here on the server side, I don't believe. So we'll take a look at the results here. Let's see. Okay, so not very pretty, but we get our home page with our welcome to SSR. And if we hover up here, you can see that our title has the -- home. If we click about, you can see it navigates to our about page and updates the title. And I think you could probably tell just by the speed and smoothness with which that navigation happens. But if you really wanted to verify, you could look down in here in the network tab, and I think you'll be able to prove out that when we do this, we're not making any new requests to the network when we change pages. That's all happening client side. However, if we were to refresh this about page, we're going to get right off the bat pre-rendered about page versus home. We get our pre-rendered home page. Actually, oh, home is not /home. That is just a failure in my links, but that's what we would get. And we can see this over here again using curl. So if we curl our about, we get our about page versus if we curl our home page, we get our home page. So that's pretty cool. We now have achieved quite a bit of our goals. We have a very simple React app. We have it doing the initial render server side and producing dynamically generated titles, but all that logic is kept within the React application. The next thing I wanted to do was to build on the complexity just a little bit more and include a route that's slightly more complex. This isn't going to take things too much further. I just wanted to make sure everything was going to work out okay here. So we had previously the two routes about and /. We've now just added this team member here, which has a path parameter in it. You'll notice here called member. So we have our team component page here, and we're using a React hook to extract this member from the path params. And then we're just going to use that for the title as well as in our display here. And I've updated our about page to give us some links. So we now have a member list here of very real team members, definitely not just generated by the Faker library or anything. So if we go over here to our app, we've still got our working home page here and our about page. If we refresh, we should get this about page again. We've already kind of shown that's working. So if we click one of these, we see meet Daryl Lowe here with some lorem ipsum text. And you see the title up here, so that is working. Now what happens if we curl? Sure enough, it's all working here. We get our title with Daryl Lowe included and our lorem ipsum text. Our lorem ipsum text is actually going to change up on every single one of these requests or client-side renders because it's just being generated randomly in the component. But you can see things are basically working as expected. Okay, continuing to build on the complexity of this app, we're going to start to find where this technique potentially starts to meet its limits. What we've done here is we've gone ahead and created a simple API for ourselves. So we have API/members here now defined with a simple route here that's going to get us team member information by member name. So we're just taking what we were doing before on the client side here, generating an about section with some lorem ipsum text. And we're also adding here now a username, and we're going to return that as JSON. So going back over to our client side team member page here, we're no longer generating that about text client side. We've also added a username section. We are instead loading this data from the server, and you'll notice here that we are calling useEffect. UseEffect is a React hook here that's signaling that what we're going to do inside here is asynchronous. So this code here is not going to get invoked or be expected to complete or anything within the initial render pass, right? And that's why we've also added here this simple load wrapper, which just takes an isLoading from our state. So when isLoading is true, we're just going to return some loading text. Otherwise, we're going to output our children, right? So on the first render of this component, we're going to just have this initial state here. So we're just going to end up rendering loading because our isLoading is initially going to be true, right? So what's going to happen then, though, is that on this initial load, we'll call load user info, and that's going to make a fetch request here to our API endpoint. Again, all asynchronous, so at this point our component's already rendered. Once it's done, we're going to update the state, which client side at least, that's going to trigger a re-render of this component. But what you'll find with the server side rendering is it's just a single render pass, so we're not going to hit any of this code server side. So we'll see this in action here. So here's our member page, and if we refresh it, well, that was really fast, but there you go. You see the loading there that came up for a minute, and then eventually our page came back. So if we were to curl this, if I can type correctly. Okay, you'll see here we still get our title, which was generated by the text that we supplied up here. But what we get down here in our content is just this loading ... Now, that's going to be fine in a lot of cases. It still potentially meets our criteria of letting us serve up dynamic titles. And oftentimes, I think this is exactly what you're going to want. You're going to want to kind of render back the page template. You're going to, maybe want to include things like, favicons and any sort of metadata and stuff like that. Kind of let the server handle that. But then the rest of this fetching will be done, asynchronous AJAX style. That's not that strange. Where you start to run into problems, though, and some limitations is, let's say that the title up here, what if we didn't want it to be set to member? What if we actually wanted it to be set to nickname? Well, we don't know about the nickname yet, right? In order to find out about the nickname, we have to execute some asynchronous logic. And if we're depending on Helmet and our application logic here, our React application logic to provide that title, we're not going to be able to supply it that way. Okay, I think we can expand on this technique just a little bit more though and get pretty close to our original goal here without making too much of a mess. So I'm going to go just a little farther here. There's a little bit of background work needed to set this up. The first thing you'll notice here is we've added this .m file, and we've gone ahead and we've set the location of our API here. Now, you might have noticed before when we were making our API calls, we were just hitting slash, so we were calling back to the origin. That's not going to work for us anymore, and we'll come back to why here in a second. Just really quickly show you in order to get this to work. It's pretty simple. We're just making use of the common node dependency.env, which is just going to pull in our environment along with anything in one of these .env files. And then a little bit of Webpack magic here. This define plugin is defining a global variable called env and then passing it all the contents of our process.env. Process.env is where this .env is going to set all those values. With that in place, we should have inside of our React application a global variable called env, which will have any of the values we set here as well as anything we set in our host environment. Another little change here. We've abstracted the network call to a little service utility here, which makes use of that env value. Just a little bit of setup here to make Typescript happy. But basically doing the same thing as before, we're just using the fetch API to call that endpoint and get the JSON data back. You'll see why in a second, why it was important that we abstract that out. So going back to our team members page here, we are doing basically the same thing, but we've just now simplified this a bit, get by member name. Okay, great. But now what is all this giving us here? Okay, well, within the context of the client state, you'll notice some other small changes here. I am actually making use of the contents of this fetch, this user info, to set our title, right? The user known as username is now going to be what our title is going to be rather than what we were setting it to before. But as you'll recall, we talked about how that this isn't going to really work server side because this is all asynchronous. But we can do a little bit of hackiness here to make something like this work in a way that I don't think is too terrible. So what we've done here over on the server side is we're going to leverage the Express middleware. So we still have our server.getStar, and nothing much has changed here except for you might notice this one line here has changed a bit. We're just always setting this title to helmet contents.title, right? Now we have this potential override value called page title, which can be set on the request. How does that happen? Well, that's what this little bit here is for. So we're basically setting up some middleware, and inside of here, and we're going to have some route matching logic, right? And so if we see a request for team colon member, what we're going to do here is we're going to leverage this same service that we invoked on the client to make the same API request, and we're going to set up the same title here, right? So that is one of the reasons I mentioned I'd come back to. This is why we abstracted the get member name out so that we could reuse that logic server side. And that gets at one of the problems with this. We are definitely now stuck maintaining this logic in two places. We've reduced that problem a little bit by abstracting the service call, but not very much. We could probably go a bit further and maybe abstract the entire title generation method to something shared, but you're still stuck with this here. So if we decided that we wanted to say change this route from team member to say awesome team / member, we're now going to have to know, to update that both here in our client-side routing as well as over here in our server-side route matcher. If you're only doing this for a handful of endpoints, then this technique might be useful, and I think you could probably maintain it okay that way. But that's definitely something to keep in mind. That's a major drawback. But it should work. And in fact, let's go ahead and just show that it is working. So if we curl our endpoint now, we now see in our title the user known as Nia97. So great, it's taking our updated logic into account. And if we do the same thing over here, we'll probably get a different nickname, but we will in fact get a nickname up here. It's going to be different because we're just randomly generating that with lorem ipsum text. So it's going to change every time we refresh the page. It even changes between what the server returned and what the client returned if you saw that flicker. But that's just an artifact of the fact that this data is all fake. But yeah, so that is basically working. Really quick before we close up, I want to mention one more thing you should be aware of with the way this is written. I think I mentioned earlier that this helmet.render static had a bit of a smell to me. Well, one of the issues with it is that um, this helmet here is this global object we're importing, and we're pulling state off of it, and that state is in some way determined by what happens when we run our React application when we invoke this render.toString. Right now, there's nothing asynchronous happening between this line and this line, so that's okay. But it's important to remember that if we were to do something asynchronous here, if, for example, this logic inside of the page title matcher, which calls out to an API, were instead here, then we could have some serious problems because we would invoke this build React app method and whatever state that's relevant to this particular user session would be built up. But then we'd go off and start potentially processing other requests once we've made that network request. So this state could get built again and what's on Helmet could get swapped out. And by the time we come back here to this scope to continue, what's on Helmet might not necessarily be this user's reflective of this user's data. So that's pretty scary. That's a common issue you can run into with Node applications. In this case, we've basically mitigated that by putting all the asynchronous stuff up front. There is a fork of React Helmet called React Helmet Async, which attempts to make this library safer by allowing you to pass in a context and a provider to Helmet that can be request specific. So then if you did asynchronous stuff when you returned that all that context that Helmet has built up when executing this would all be kept within the scope. I think it's definitely worth considering switching to that library. That's just something I wanted to make everyone aware of. And another quick gotcha, I mentioned earlier that I switched over to pulling in the API URL from the environment. And well, in addition to that, just being a good IGN in general, because you're not generally going to want to host your API on the same service that's delivering your static files and so forth. It also is necessary to make this work server side because you got to remember that when this method is executed within the context of the server, there is no origin. It's not like it's been served up to a browser from a particular origin. So it needs to know the full path of the API it's going to be calling. If you don't do that, you're going to get some funky errors here. So I think that really ties a lot of this together and shows how far you can kind of go with this technique. I think there are some arguments to be made for if you're going down this path for leveraging a framework like Next.js, which does a lot of this out of the box for you, but it is also a framework which comes with a lot of opinions and may not fit within the context of a legacy application. But that's definitely something that you might want to check out next.